Day 3, Problem 1. A tower has a diagonal support cable. The cable is 100 meters long and attaches to the ground 20 meters from the base of the tower. Question A, sketch a diagram. We could use just a horizontal line to be the ground, and then for a tower, perhaps just a simple rectangle shape might be the tower. No need to get too fancy. And to help support the tower, against the wind, it says there's a cable that's 100 meters long. So somewhere on the tower, up here at the top, the cable, probably made out of steel or some strong material, is attached, and it comes diagonally, and then it's attached into the ground right there. We know from math class that this creates a right triangle shape with a 90-degree angle in this corner. We're told that it's the cable itself that's the 100 meters, and so it's this diagonal side that is the 100 meters. And we're also told that the cable is attached to the ground 20 meters from the tower. So the bottom of the triangle is where the 20 meters is. And so as you look at this drawing, hopefully you're also able to see a right triangle shape in that drawing. Okay. Part B, use the Pythagorean theorem to find the tower's height. So it is this side of the triangle that we do not know. And that is one of the two legs of the triangle, because the sides of the triangle where the right angle is formed are the sides that are called legs. Visually, it doesn't appear to be the short leg that's missing. This one here seems to be the short leg. And so this side of the triangle is the leg that we put the variable b on from the Pythagorean theorem. So let's do the Pythagorean theorem. A squared plus b squared equals c squared. A is 20. B is the side that has a variable, and c is 100. Here's the equal symbol. We want to solve for b, and so we're going to need to remove the 20 squared, which has been added to the b term. We can do that using subtraction. 20 squared, subtract 20 squared, makes 0, and the b term comes straight below. On this side, we need to find out the answer for 100 squared, subtract 20 squared. Let's do that on scrap paper. First of all, 100 squared, what does that make? So we need 100 times 100. Okay. We could go through an entire process of working this all out piece by piece, or try to do it in a quicker fashion by starting with 100 and then recognizing when you multiply by 100, you can do that by putting 2 additional zeros onto the end of your starting number. So 100 squared is 10,000. Now the other number we needed to figure out was 20 squared. And so 20 squared, what is that? Well, 20 times 20. Again, we can go through our normal multiplying process and work this all out, or try for a faster way to get the answer. Now, 2 times 2 is 4, and therefore 20 times 20, which has in total 2 additional zeros on it, would be 400. So 10,000 subtract 400 is what we need to find out. So here's 10,000, and we want to subtract 400. Again, we can go through all these steps with some borrowing and so on, or try for quicker, more mental ways to get the answer. 10,000 subtract 400 will be 9,600. So this is 9,600. To solve for b requires using a square root. And so the square root of b squared is b. And on this side, we need to do the square root of 9,600. Is this a whole number If not, we could take a decimal guess out to 1 decimal point. Let's find the square root of 9,600. Okay. On the scrap paper, we're trying to find the square root of 9,600. Recall that we'd already figured out that 100 squared is 10,000. Okay. 9,600 is less than 10,000, and so our square root is less than 100. Is it 90? Maybe 90. What is 90 squared? Well, 90 squared, 9 times 9 is 81 with 2 zeros. No, that's too small. Maybe it's 95 squared. What's that make? Okay. Well, let's do 95 times 95. 5 times 5 is 25, carry 2. 9 times 5 is 45, plus 2 is 47. Start the next row with 0. 9 times 5 is 45, carry 4. 9 times 9 is 81, plus 4 is 85. And add together. 5, 12, carry 1, 10, carry 1, 9. 9,025. It's close to 9,600, but still too small. Probably not 95 squared. What about 98 squared? How close does that take us to 9,600? Let's do 98 times 98. 8 times 8 is 64, carry 6. 9 times 8 is 72, plus 6 is 78. Start the next row with 0. 9 times 8 is 72, carry 7. 9 times 9 is 81, plus 7 is 88. And add together. 4, 10, carry 1, 16, carry 1, 9. 9,604. This is just a tiny bit larger than 9,600. Okay. What that means is that the square root of 9,600 is not quite 98, but it's very close to 98. So how about taking the guess 97.9? So our guess is that this is approximately equal to 97.9. Okay. The variable b is written on the side of the triangle that is the tower, and so we've figured out that the height of the tower is about 97.9 meters. Now, day 3, problem 2. Graph figure ABC with these vertices. Point A is 0, 2. That's here. Point B is 1, 1, and that is here. And point C is 5, 3. That's here. Connecting together, we have a triangle shape. And that's part A of this question. Now part B, graph the dilation using a scale factor of 1.5. Let's create a larger triangle, the same shape, but multiply these coordinates by 1.5. That will get us the coordinates of the dilated image. So for A prime, we need to take 0, 2 and multiply by 1.5. 0 times 1.5 is 0, and 2 times 1.5 is 3. So A prime is 0, 3. That is right here, A prime. Now let's find B prime. To find B prime, we take the ordered pair for B and multiply these numbers by the scale factor 1.5. 1 times 1.5 is 1.5, and 1 times 1.5 is 1.5. Here's the origin, 1.5 to the right, 1.5 up, And here is point B prime. And now point C prime. Take the ordered pair of point C and multiply these numbers by 1.5. 5 times 1.5 is 7.5, and 3 times 1.5 is 4.5. So from the origin over to 7.5 up to 4.5. Here is C prime. Now we can take another color pen and connect these new dots together. The red triangle is similar in shape to the original black triangle, but it is larger in size because we had multiplied distances by the scale factor 1.5.